Okay, in this video we're going to look at scalar and vector projections. So again, this is not going to replace how you would go through the proof with your teacher and work in groups with your classmates to see exactly why this is. But this is going to help you work out what a scalar vector projection is when you're doing the calculation part of it. So it works like this. Suppose you got this vector A, and you got this vector B, and they're tail to tail. So projection means if I want to project A onto B, that means I'm going to drop a piece of A on to a piece of B. And that result is going to be a scalar. And when I do that, that's going to be calculated by doing A dot B divided by the magnitude of B. Now, if I had those same two vectors, so again, just drawing A, B, and I wanted to do B on A, that means I'm going to project B onto A. So that's going to be B dot A divided by the magnitude of A. So you always divide by the magnitude of the one you're projecting onto. Now, the projection of A on B does not equal the projection of B on A. So I'm going to show you that in a minute. So again, let's get some numbers in here. So we're going to do an example on our 2, but this works for 2 space and 3 space. So I'm going to say that A is 2, 5, and B is negative 5, 12. And I want to project A onto B. So we're going to go up here. The first thing we need is a dot product. So when you do the dot product algebraically, you are going to get a scalar. So we're going to go 2 times minus 5 is minus 10. 5 times 12 is 60. So that'll give me 50. Now notice I'm projecting onto B, so I'm going to need the magnitude of B. So minus 5 squared plus 12 squared. Work that out. And I could take the square root there. So the projection, the scalar projection, remember scalar is just a value, it's not a vector yet. So the scalar projection of A onto B is going to be equal to 50 divided by 13. And again, we figured out A dot B and then magnitude of B. Now if I wanted to do B dot A, well, I already said that those are not equal, so let's just make sure about it. So then I'm going on to A. So again, I still got to do the dot product. So I'm going to go B dot A. What was that, 2, 5? Now, that's going to be minus 10 and 60. Now, A dot B is equal to B dot A, but the projections aren't equal. So I'm going to get 50. Now, because I'm projecting onto A, I'm going to need the magnitude of A. So the magnitude of A in this case, remember A was 2, 5. So when I work that out, it's going to be root 29. So the projection of B onto A, the scalar projection is going to be equal to 50 divided by square root of 29. So you can see that those projections are not equal. Now that's the scalar part of it. If you want the vector projection, well, you've got it half done already. So if we look back up here, if we're projecting A onto B and I want the vector projection of it, so I want you to think of it this way, right? You've dropped it, and now in order after you drop it, or dropping vector A onto B, and you're going to put that vector symbol in because you want a vector, you need a vector to multiply A by, okay? But we don't want to use B. what we want to use is a unit vector. Now, we talked about the unit vector in the last video. So what ends up happening is when you want the vector projection, so let's say the vector projection of A onto B, it's going to be that scalar projection. So, in other words, what we just did there, A dot B divided by magnitude of B times the unit vector of the one you fall on. And you can look at the last video to review how to do a unit vector. So in that case, if I'm falling or projecting onto B, I'm multiplying by the unit vector of B, which would be B divided by magnitude of B. And if I want to do the vector projection of B on A, talking about vectors, so that's going to be B dot A divided by magnitude of A. Now, because you're projecting on to A, you're going to multiply that by the unit vector of A. So we've already, let's do the first part there. We've already got this part, okay? We've already got that part, that's this. So now just you need that unit vector. So unit vector is B divided by magnitude of B. So remember B was minus 512, and we already have the magnitude because we had to divide that in the scalar part. That was 13. So the unit vector is minus 512, and each of those divided by the magnitude of B. So this right here, let me just change my brackets. This is my unit vector. In order to get my vector projection of vector A onto B, I'm going to take my scalar projection, which I already calculated was 50 over 13, and I'm going to multiply it by the unit vector of the vector that we projected onto, which was B. Now you can leave it like that. I like to multiply them out, distribute them. So 50 times 5 is 250. And making sure we do that correctly, 50 times 12. If I did that right, is 600. Now, was there a negative in there? Let me see here. Yep, one of them was a negative. So that is going to, yeah, right there. Forgot my negative there. I thought so. So that's going to make this one minus 250 over 169 and 600 over 169. So again, you got two parts. You've got the scalar projection and the vector projection. So if you're looking at what you're going to use, so this is what you're going to use. Let me just change the pen color here. So this is what you're going to use for vector projection of A on B. And this is what you're going to use for vector projection of B on A. And this is what you're going to use for scalar projection of A on B and scalar projection of B onto A. Okay, we will see you